Alright, so if you let the function a of x to the n plus whatever over c times x to the k plus whatever, it's just saying that you have if you have a polynomial over a polynomial, then if the polynomial on top is smaller than the polynomial on bottom, meaning a cubic over a quartic, right? That's smaller. A cubic is smaller, right? Then you're going to end up with a horizontal asymptote at the x-axis. If n is equal to k, then you'll have a horizontal asymptote at a over c, whatever that might be. Like we talked about here. If it was 6 over 3, then it'd be at 2. It'd be a horizontal asymptote at 2. Okay? There's a vertical asymptote, or what they like to call an end behavior of the graph, at when the top polynomial is larger, has a larger degree than the bottom polynomial. Okay? So if you have a cubic over a quadratic, okay, that's going to produce a vertical asymptote. Okay? Now vertical asymptotes are always produced, though. Always produced when the bottom, or h of x, goes to 0. Whenever that bottom polynomial hits 0, you're going to have a vertical asymptote there too. Does that make sense? So, yeah. So, let's look at this. We talked about these. Remember, 2x plus 5. All we're saying is 2x plus 5 cannot be 0. We solve for that. That would be negative 5 over 2. Negative 5 over 2 cannot equal 0. That's it. That's your vertical asymptote. Does that make sense? Okay? Alright. So x cannot be that number. It creates a vertical asymptote. That's what you're doing for all of these. Then here they're asking you, where are the holes in the graph? Can we break that up? That'd be, no, that's not factorable. And that's two things that multiply. Again, here we broke this up. X squared minus 5x minus 6. What's two things that multiply to be 6 but subtract to be 5? 6 and 1. So it's x minus 6, x plus 1, right? And then those are where your vertical asymptotes would be. Now you can also see that because it's a square over a square, it's 1 over 1. So there's also going to be a horizontal asymptote at 1, a over c, at 1. Okay? What else do we got? What I really want you to be working on here is like 41. For 41, oh, that's weird. Oh, there we go. For 41, I'm going to give you two, oops. Oh, I wasn't even showing you. Okay, anyways, for 41, the important thing is, I'm going to give you a quadratic over a cubic, or quadratic over a quadratic, or a binomial, like linear binomial over a quadratic, right? And what I want you to do is factor it. So they're going to be pretty simple. They're going to be factorable, right? This one was factored. You see it? And see how this one's factored out? And it has x plus 3 over x plus 3. Now before you do anything, you have to say, well, x cannot be, well, it can't be a negative 3, right? Because x plus 3. X plus 4, so it can't be a negative 4. And then x minus 5, so it can't be 5. So right off the bat, you got to tell me what x cannot be. Or in other words, the vertical asymptotes. Okay? Secondly, you're going to reduce this function. It's called rational functions. I want you to be able to reduce this. That just means that the x plus 3 cancels with the x plus 3. And you're left with x plus 3 over x minus 5 times x plus 4. And then you're going to multiply those two together and get x squared minus x minus 20. Right? Just simple math. Everybody on the block gets a paper. X times x is x squared. X times 4 is 4x. Negative 5 times x is negative 5x. That's a minus x because you got 4x plus negative 5x is minus x. And then you've got the 5 times the negative 5 times 4 is a minus 20. And so you'll end up with x minus 3 over x squared minus x minus 20. Okay? And so that's going to be really what I'm looking for today. Is can you factor? Can you break down the polynomial, the rational polynomial, right? Can you tell me where there's some asymptotes, whether it's horizontal or vertical? And that's it.